Hi, this is Angela Galloway. I'm your Math 146 instructor, and I was going to go ahead and show you just a few more examples of some voting methods that I did in my lecture class the other day, and so I thought it might help you as well, either if you're one of my online students or if you're a lecture class student that happened to miss class the other day. So looking at this is the worksheet that I will have for you saved in Blackboard, and so you can look at it. It's pretty simple. We're just doing another example similar to the one that we did in the lecture notes and ones that you're going to see in your homework. So when you look at this, it says there are 5 candidates for Student Council President. They just happen to be A, B, C, D, and E. That makes it easy, right? And we're trying to find the winner for each of the different methods. So this is going to be our chart here where we have all the rankings and we have the number of votes. So remember that with the rankings that whoever is written in first, those are the people that you would have put in first place. So the people that voted here said they wanted A first, then C, then D, then E, and then last place B, right? So 21 people said that. 19 people said they would want it D, A, E, C, B, etc. All right, so that's how we read those. Hopefully by now you're kind of familiar with that if you've looked through the lecture notes or if you've done any of the homework. So looking at where I actually worked these out, so I'll have these posted for you as well to kind of look through. They're a little different than the lecture notes I would have the lecture videos on already, or the ones that are posted for the online class, because these are the ones I just did this week, so they are, you know, updated. So you won't see this in the lecture notes, but I'll add these on so you can look at them. But here we've got what we're looking for. We've got our rankings there. And so for the plurality winner, remember you're just looking for the most first place votes, right? So most first place votes, we're just looking at that first column, right? And then just adding the votes that go with it, right? So we see that B here, it was first place here, which was 17 votes, but then also first place here, which was 6 votes. So you want to make sure that you include all the votes that they were first in the ranking for. So that ends up telling us that B is going to win overall because they have the most votes, right? Now, is there a majority winner? And we would say no. The reason why there's not is because they don't have more than half of the votes, right? So you could either add up all these votes, divide by 2, and add 1 to get up to how many votes they needed. Or a quick way to do it is just to look at, does B have more votes than everyone else combined? So that would be another way to think of majority, is if you have a majority of the votes, you have more than everybody else combined. So if that's not the case, then you don't have a majority. Sometimes that can be easier or faster to do than adding up all the votes, dividing by 2, and all that stuff. So B is not a majority winner, but they are the plurality winner. So that means nobody has a majority. Now the next one is the pairwise comparison winner. Pairwise comparison is where you compare all the pairs, right? Now if you have a lot of options, then that ends up giving you more pairs, right? So not the funnest method to do if you have lots of options because it could take you a while. But with this one, we first wanted to see how many pairs could we possibly have, right? So we use combinations to figure that out. Combinations is something you can find on your calculator. If you have the scientific calculator, you're going to go to the PRB button. There should be a probability button is what it stands for. And in that, there should be the NCR option in there. If you have the graphing calculator, you would go to the math menu and then go over to probability, and then it will be under there. Okay, so when we put it in our calculator, we type in this number first. This number is our number of options here. Then we'd go and find the NCR that would be somewhere in our calculator, and then we punch in the number 2. We're always going to use 2 because we're always putting our options into pairs, right, which is groups of 2. So in other math situations, you can use combinations to talk about any groups, any, if you want to put people in groups of 3 or 12 or whatever. But in our situation, we're always going to be doing pairs, so that number is always going to be 2. So when we do this, 5 choose 2 is 10, so that means there's going to be 10 options that we're going to have to do, which sounds terrible, right? But luckily, usually when you're doing these, you can sometimes get away with not doing all the pairs because sometimes it becomes evident who's going to be the winner. And that's kind of what happened in this case. So for ours here, I did all these different pairs. So I just wrote out all the ones we would have to do. So A versus B, A and C, A and D, A and E. Then we start with the B, B and C, B and D, B and E. Then C and D, C and E, and the very last one was D and E. So I kind of ran out of room to write that, but that would be our 10th pair. So what happens here is when you start doing these, you're going to notice that actually A wins every single one that it's paired in. So because of that, we were able to kind of stop at that point and say, well, they're going to be the winner because nobody else could win more than 4 pairs since A has already won all of its pairs. But the way we do the pairwise comparison is we're looking up here, and when we're comparing just A and B, we're basically looking at all the rankings and saying, all right, let's pretend like everybody only had A and B to choose from, right? So you could go through here and mark all these out if you wanted to. You don't have to. I'm just doing that to kind of show you visually what we're looking at if you're kind of confused with how to do it. So now we would be saying, all right, you only have A and B to choose from. So if A comes before B in the ranking, then A is going to get all the votes, right? If B comes before A, then B is going to get all the votes. So that's what we're looking for here. So we see on this one, A came before B, right? So when I draw this out, I kind of just draw a little kind of tally system here and say A is going to get those 21 votes, right? Next, A here comes before B again, so it's going to get those 19 votes. So I wrote 19 here. In the next one, B comes first, right? So it's going to get 17. So it got those 17 votes there. Then on the next one, A's before B, A gets the 7. B's before A, so B gets the 6, and then B is before A, and so it gets the 2. So that means A's got 21, 19, and 7 votes. B has 17, 6, and 2. So we add all these together, and A comes out with 47 total, and B comes out with 25. So that means A would be the winner of this pair. Okay, so then how do we figure out the winner? Well, we do this for all the pairs, and then we see who won the most pairs. Now, if there is an option that wins every single pair that they're in, then we find out in section 2 that that's called the Condorcet candidate, but that also means in the pairwise comparison that they're going to win. So you could stop at that point if you find out that somebody has won all of their pairs. So we go through here, A wins against B, C, D, and E, so they won 4 pairs, so they are going to be the winner. Now you could go on and finish the rest of these, comparing the other ones, and kind of just see that that is the case, that A would still win, but I didn't want to because, you know, I was doing it in class and I figured by that point everybody had had enough of it. But you can do that just to kind of see that it would be the case. All right, the next thing that it asks about is the Boredom method and finding the Boredom winner. The Boredom method is the weighted sum method. Okay, and so for that one, we look at the number of votes that the ranking had, and then we multiply it by the place that this option was in, and the number of points we're going to give it for that place depends on how many options we had, what place you were in, etc. And those are all our Boredom points. So with Boredom points, we always give last place 0 points. Okay, so I think that's the easiest way to think about it. The other way to think about it is that they say first place always gets N minus 1 points. But I realize that students sometimes don't like when we put letters into math expressions, right? So N is talking about the number of options. So if you have 5 options, then N minus 1 would be 4, right? 5 minus 1 would be 4. So that means first place would be 4 points. But I think it is a little easier to just remember 0 points for last place, and then you just keep adding a point until you get up to first place. So that's what I usually tell students to do. So that means 5th place for this one is going to be 0 points, 4th place is 1 point, 3rd is 2 points, 2nd place is 3 points, and 1st place is 4 points. And so this was how we did the Boredom. So you see this first 21 here, that's the number of votes this ranking got. So you see this 21 occurs in all of these, right? Because all of them were talking about 21 votes for the first ranking. But what changes is what place were they in. So A was in first place, which is 4 points, right? And so that's where this 4 comes from. So 21 times 4, that's going to be how many Boredom points A gets for that first ranking. You see for B, they were in last place in that first ranking, which is 0 points. So they actually get 21 times 0, which is 0. So they get no points for that first ranking. And then we do the same for all of them. So the next one, there's 19 votes. We look at where A is. A is here in the 2nd place, and we go up and see that that's 3 points, right? So there's the Boredom point, and then we just keep going. Now when you put this in your calculator, you can put it in just like it looks like here. Just do 21 times 4 plus 19 times 3. You don't have to worry about parentheses because your calculator will use order of operations and do the multiplication first. Some of them for smaller numbers you may not even need a calculator. You may be able to, figure them out individually and then add them all up. But it just kind of depends on how big the numbers are. So when we get to the end of this one, I did all the Boredom sums here, added them all up, and you see that 193 is the largest sum. So A would be the winner for the Boredom method. And then the last method it asked about and that we learned about is the hair method. The hair method, we start off just like the plurality method. In the first round of the hair method, it's just the plurality method. So we're just looking at first place points here. So for first place points, A, B, C, D, and E, we had 21 for A, right? B had 23 because they were first place here and here. So we had 17 plus 6, right? So that's where we got the 23. C had 2. They were first place there with 2 votes. D had 19 from this one. And E had 7. All right, so let me go up here and erase some of this so we can kind of talk about what we're looking for there. So what we do is in the first round, if nobody has a majority, then we have to go on to the second round, right? So if somebody has a majority in the very first round, then that's great, you're done, okay? But if they don't have a majority, then you do have to keep going until somebody gets a majority. And eventually, one of the options is going to have a majority, okay? It may take you 2 rounds, it may take 7 rounds, depending on how many options you have. But eventually somebody will get a majority. So in the first round, nobody had a majority here. So for ours, if we add up all these numbers here, that's going to be our number of votes. And so we get 72 votes total. We divide that by 2, and that gives us 36. And then because the majority has to be more than half, we would add 1 to that number, so we would have more than half, and that gives us 37 votes. So that's kind of the magic number we're looking for in this one. So none of these have 37, so the hair method says we're going to eliminate the option with the least number of votes. So in this one, the least number of votes would have been C, right? C only had 2 first place votes. So that means up here, C is no longer an option. but we still want those people's votes to count. So what we're going to do is we're going to say, looking at the ranking, if these people couldn't have C, they said they would take B, right? And so B is their next choice. So B is going to get these 2 votes that came from C, all right? And that's because in the ranking, B came right after C. So now in the second round, we have 21 for A still, 25 for B now because we've added those extra 2. C is gone, D has 19, and E has 7. All right, so in that one, the least number would be 7, so E will be eliminated. We go up here to E and eliminate it, and we see that if those people couldn't have E, they would choose D, right? So D now is going to get E 7 votes, all right? And then for the next round, we now have A at 21, B at 25, and D is going to be at 26. Now all of these are, pretty close voting wise, but we still have to eliminate the one with the least number of votes. So that's going to be A in the third round. So we'll go up here and eliminate A. Now these people, if they couldn't have A, they said they wanted C, but we already eliminated C, right? So they can't have C. So if they can't have A or C, their next option would have been D. Okay, so D is going to get those points. So you would just keep moving down this ranking until you get to an option that's still available. Okay, so we would add on A's 21 points or 21 votes to D, and now the very last round, we will still have B at 25, and now D has 47. Okay. So this is D and this is B. So our final winner for the hair method would be D, because at this point we do have a majority, right? Somebody does have a majority. So we see with this example that different methods gave us different winners, right? There are some examples where every method will give you the same winner. So it kind of just depends on what the rankings look like, how many options you have, how many votes you had, and which method you're using. So you might then wonder, well, how do I know which method is best, right? And so we're going to learn in 16.2 that there's not really one perfect method for every situation. So you kind of would have to figure out what's most important to me. Do I want to make sure the majority candidate wins? Do I want to make sure that whoever has a plurality of votes wins? Whatever. And you might be able to decide which one you would think would be the most fair in the situation you're looking at. So 16.2 is going to go into some of those unusual circumstances that happen when you think a certain option should win, but it doesn't, and it's going to go into those. So in 16.2, you'll get some more examples to go over for voting methods. So if you still feel like you're not totally sure on them, you will get some more practice in 16.2. All right, so I hope that this helped at least give you a few more examples to look over. I'll do the same thing with apportionment, which is what comes up in 16.3, and I'll probably get to that next week, so I will post something on that as well. But remember, if you have any questions, you can always email me at angela.galloway@kctcs.edu, or you can click the Ask My Instructor when you're working in my math lab, and it will send me a link to the problem you're working on, and I can respond that way. All right? So I look forward to hearing from you, and good luck working on your voting methods. Thanks.